Hi, welcome to my video on the motion of a particle on a line, a straight line. This is the introduction video. Introduction to the motion of a particle on a line, again a straight line. The s of t is a t to the n plus b t to the n minus 1 plus c t to the n minus 2, etc., etc. And again, this m is s of t is the distance in terms of time and is in meters. Represents the position of an article on a straight line where s is the distance in meters, denoted by m from 0. T is the time in seconds. Seconds is denoted by s. Don't get confused with the s of t, but s for seconds. And t is greater than or equal to 0 because the time got to start at 0 and be positive. And let's do an example where the s of t equals 2t plus 1, and m is in meters, and time is greater than or equal to 0. So this is the s of m is the position in meters. So let's look at what at 0 seconds. So the s of 0 equals 2 times 0 plus 1. 0 plus 1 is 1. So at 0 seconds, the particle is at 1. So this is 0 seconds, it's at 1. And but about 1 second. So the s of 1 is 2 times 1 plus 1. 2 plus 1 is 3. So at this is at 0 seconds. At 1 second, it's at 3. So t is 1 second. It's at 3 meters from 0. And this is the starting point. It starts at 1, and notice it's moving right. So what about when t is 2? So the s of 2 is 2 times 2 plus 1. 4 plus 1 is 5. So at 2 seconds, it's at 5. 3, 4, 5. So this is 2 seconds. It's at 5. And 3 seconds, the s of 3 is 2 times 3 plus 1. 6 plus 1 is 7. So at 3 seconds, that's a 5. At 3 seconds, t is 3. The object is at 7 meters from 0. And again, it starts at 1 when the time is 0. So now let's have a look at this expression in terms of x and y. So we have y equals 2x plus 1, which is linear. And notice that the slope of this line is 2 and it starts off at 1. Because this is a line, it starts, the y-intercept is 1, and the slope is 2 over 1. So you rise 2, run 1, rise 2, run 1, rise 2, run 1. And this is the line that represents this function in terms of x and y. But also notice that this is very similar to, this is the y, this is the x, so it's 2x. So this really starts off at 1, which is, again, the y-intercept here. But in terms of y equals 2x plus 1, the x belongs to the real, so the x's can be negative also. And the y's go on up and down forever. But this is not true in terms of time, because we got to start at 0 time, and time goes greater than 0. So I just wanted to explain that. But it's very similar to a linear motion, because it's this s of t equals 2t plus 1, and that's the degree of 1, so it's linear. So let's continue. What about the derivative of the s of t? The derivative of the s of t is denoted by t prime. And the derivative of the s of t would be, let's see, the d dt, derivative of s in terms of t would be ds dt. So ds dt is the derivative in terms of t. So that is denoted by a velocity. Because we have s of t, so that's a distance. So we're doing a derivative of the distance, s, in terms of time. So that gives us, we have a velocity. So velocity is the distance divided by time. So again, the velocity, vt, is the s prime of t. So find the s prime of t, or of each. That means we're finding the vt, we're finding the velocity. So the s prime of t is, derivative of 4t is 4. Derivative of 1 is 0. So the velocity is, and it's 4 meters per second. And we have another function, s of t, but this one is quadratic. So the s prime is, derivative of t squared is 2t. Derivative of a negative 3t is negative 3. So the velocity is 2t minus 3 meters per second. And let's do another one. T prime, again, remind you that t prime t, s prime t is the velocity, is the derivative of the distance over in respect to time. So we have a cubic, so that's a 3t squared plus 2t minus 2. And that's the velocity occurring at t. And we have a fourth power, so the derivative, velocity, 1/4 times 4 is 1, so that's t cubed. 3/2 times 2 is 3, t to the 1. Derivative of negative 6 is 0. Again, you're doing the power rule, so 4 times 1/4 is 1. And this 4 minus 1 is 3. 3/2 times 2 is 3. This decreased by 1 to a 1, and the derivative of a constant is 0. So the derivative of s prime, is the velocity. So what about the double derivative? What about the derivative of velocity? So that's the derivative of, we're doing this. So that's the derivative, and that's the derivative of the velocity, the derivative of the velocity is v prime t, and that's the same as double derivative of the position. So the derivative of the velocity is derivative 1, and that's double prime. So what we have an acceleration, so at. So let's look at it again. The acceleration is the derivative of the velocity, or it's double derivative of the position function. So again, d dt of the velocity is d dt. The velocity is ds over dt. So that becomes d squared s over dt squared. And the derivative of the velocity is the acceleration. And the acceleration, remember, velocity is meters per second. So acceleration is the meters per second, so it's really meters per second squared. So find the double derivative, double prime of t, so that's the same as doing the derivative of the velocity. So if we do the first derivative, which is 3 times 2 is 6t, and derivative of 6t is 6, so the second derivative is, derivative of 6t is 6, derivative of constant is 0. So the second derivative is acceleration. The second derivative is the derivative of the velocity. So there's the velocity, vt. So the first derivative is the velocity, the second derivative is the acceleration. So the acceleration is 6, and again it's, if we take, this is in meters, so this is 6 meters per second squared. Number 2, s of t is this cubic, so the first derivative, s prime t, is 3t squared minus 8t. Derivative of 10 is 0. The second derivative is 3 times 2 is 6t, and the derivative of negative 8t is negative 8. Again, this is the velocity. It's the first derivative at the t, and the acceleration is the second derivative. So the first derivative of the position function, s of t, is velocity. The derivative of the velocity is acceleration. Number 3, we have, we're going to find double prime, so s prime t. Derivative of 6t, negative 6t is negative 6. Derivative of 7 is 0. Double prime, which is the acceleration. And the derivative of a constant is 0. So this is velocity. This is the acceleration. And again, this is a linear, so the derivative of there is the slope. So the slope is negative 6. And the derivative of a constant is 0. Number 4, s prime. Position function is 2 times 4 is 8, t cubed. 3 times 5 is 15t squared. Negative 1 times 2 is negative 2t. Derivative of 3t is a 3. Derivative of constant is 0. So that's, again, as meters, so that's meter, just remind you, meters per second. And the double derivative is 8 times 3 is 24t squared. 15 times 2 is 30t. Negative 2t is negative 2. Derivative constant is 0. So this is meters per second squared. Again, first derivative is velocity. Second derivative is acceleration. And remind you, so just recap. We haven't finished it, but just recapping. So that's that. Acceleration A, derivative of velocity, or the double derivative of the position function. Number 5, s of t, s prime t, negative 2 times, negative a half times 2 is negative 1, so that's a t. Derivative of a negative 3t is negative 3, derivative of constant is 0, and s double prime t, derivative of t is 1, derivative of constant is 0. And again, this is meters and time is in seconds. This is the velocity, pt, meters per second, and this is acceleration, which is the derivative. So that's the velocity, so acceleration, derivative of the velocity, and double derivative of the position function. And so this is meters per second. Just a review of the article, or a particle, I should say, moving along on a straight line. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.